Okay, imagine this. You're at a drive-through. You tell the speaker what you want.
Yeah.
That's your input, right?
Right, your order.
Exactly. And then a moment later, you get your food, the predictable output. That basic idea, that back and forth, is actually a really useful way to start thinking about application programming interfaces.
It's a
APIs.
good analogy to kick things off.
Yeah, but let's, unpack this a bit. Because the term API gets thrown around a lot in software talk, and honestly, it can get kind of confusing depending on who's saying it and why.
That's absolutely right. Our sources, they definitely show that while the core concept isn't super complicated, the way people use the term API varies quite a bit.
Like different meanings for the same word.
Sort of, yeah.
Yeah.
Depends on the context. So our goal here in this deep dive is really to try and clear through that complexity for you.
Okay, good. Because we've looked at material that defines APIs really technically, but also stuff that explores how they're actually, used in the real world, powering the apps we use every single day.
Hmm.
So the mission today, get a clear picture of what APIs actually are, and maybe more importantly, why they're just so fundamental to how modern software works.
All right, let's dive in, the technical heart of it first.
Yeah, let's do it.
Okay. So at its core, an API is basically a piece of code. It's designed to do one specific thing. It takes a very specific kind of input.
Okay.
And based only on that input, it produces a predictable kind of output. Think of it like a well-defined function or a contract.
The sources had some good examples here, like the Google Maps API. You give it an input, like a street address,
Yep, that's the input.
and what comes back?
You get the latitude and longitude coordinates for that exact spot. That's the output. It's a direct, reliable exchange.
Predictable.
Exactly. Or another one, maybe more for coders, is the JavaScript array.sort API.
Ah.
You feed it a jumbled list of numbers, that's the input,
Mm-hmm.
and it gives you back that same list, but, sorted nicely. That's the output.
Makes sense. And there was that hypothetical Lyft example too, right? Like a Lyft driver API.
Right. Hypothetical, but useful. You tell it where you are and where you want to go.
The inputs.
The inputs. And its job, its output, is to find the best available driver for that trip.
Okay, so giving it the inputs is what they mean by calling the API.
Precisely. The source material uses that term, calling the API. It just means you're making the request. You're providing the specific information, those inputs it needs, so it can do its job and give you back the output you expect.
And it's super important how precise those inputs and outputs need to be, isn't it?
Absolutely crucial. It's not like making a vague request.
Right. Can't just wing it.
No. The documentation for an API will spell out exactly what data it needs. Maybe the trans has to be in a certain format, or the numbers have to be, integers, not strings.
And the output is just as specific. Google Maps isn't going to suddenly send you driving directions instead of coordinates.
Exactly. It gives you those coordinates, probably in a standard format, every single time. And even if something goes wrong, say you give a bad input,
Yeah.
the API will usually send back a specific error message as its output. It tells you why it couldn't do what you asked. Still a predictable output, just not the one you hoped for.
Okay, so that's the core idea. Input, output, specific rules.
Yeah.
But how does this connect to, like, the apps we actually use?
Right. Good question. Because these APIs aren't just floating around in theory. They're the fundamental pieces that make modern applications work. The sources really emphasize this front-end, back-end idea here.
Front end and back end, okay.
Think about an app like Gmail. There's a ton going on behind the scenes,
Oh,
right?
yeah. Receiving emails, storing it, letting you write new ones, forwarding, all that.
Exactly. The source explains that the back end of Gmail, the engine room, basically, is a collection of APIs. There's probably an API for receiving mail, one for displaying it, one for sending, one for forwarding.
Okay, so APIs handle all those core jobs.
Correct. But you, as the user, you don't interact with those directly, do you?
No, I just see the web page or the app on my phone.
And that's the front end, the user interface, everything you see and click on. So when you click, say, the little star icon next to an email.
To mark it important.
Yeah. What's really happening, the front end, that interface you clicked, is translating your action into a call to one of those back-end APIs. Probably something like a mark email as flagged API.
Huh. So the shiny front end talks to the workhorse back end using these API calls.
That's a great way to put it. And what really jumped out from the sources is that most apps we use are basically just front ends. They're built on top of a whole bunch of these back-end APIs, all working together.
And having that separation must be useful, right? Like, the front-end team can update the look and feel without messing up how emails are actually sent by the back-end team.
Precisely. It allows teams to work independently. They just need to agree on the API contracts, the inputs and outputs. It makes development faster, updates easier. You don't break the whole system when you change one part.
Okay, that makes a lot of sense.
And this leads us nicely into how the term API gets used in different ways. The sources point out three main contexts, and understanding these really helps clear up that confusion we mentioned earlier.
All right, context number one.
Internal company APIs. These are the APIs a company builds for its own apps to function.
Like the Lyft example again, when I book a ride in the app, it feels like one action.
Right. But under the hood, as you said, that single tap on Book Ride probably kicks off a whole sequence of calls to internal Lyft APIs.
So not just one API call.
Probably not. There might be a high-level Book Ride API, sure.
Yeah.
But the source material suggests that this main API likely relies on lots of smaller, more focused APIs.
Like what?
Well, maybe one API to find nearby drivers, another to check if they're available, one to actually assign the ride to a specific driver, another to verify your payment method.
Wow, okay.
Maybe even APIs for the map display or the real-time chat with the driver. It's often layered, a system of internal APIs working together.
Got it. Internal APIs power the company's own stuff. What's next?
Next up, public APIs. This is where it opens up beyond just one company.
Okay, so internal is for their own use. Public means for everyone.
Sort of. It means the company decides to make parts of their back-end functionality available to outside developers. They publish instructions, documentation, saying, here's how you can use our system to do X, Y, or Z.
Ah, okay. The Twitter API was the example here.
Yeah, a classic one. We all use the Twitter app or website, and that uses Twitter's internal APIs.
Like we just discussed.
Right. But Twitter also offers public APIs. This means someone with coding skills can write their own program to talk directly to Twitter's backend.
Bypassing the official app entirely.
Exactly, to do specific things. The source mentioned the Get User Timeline API.
What does that do?
If you call that public API correctly, providing a username as input, Twitter's backend will send you back that user's recent tweets.
Not in the app view, but as raw data.
Precisely. Usually in a structured format like JSON.
JSON, you mentioned that. JavaScript object notation.
That's the one. It's just a standard text format for organizing data so computers can easily understand it. Think of it like a really neat, predictable list of information.
Okay, but why would someone want the raw tweet data instead of just using Twitter?
Great question. This is the power of public APIs. They let developers build new things on top of existing platforms.
Like what kind of things?
Well, the source gave a couple of cool examples. One was a university project that used the Twitter API to analyze the sentiment, positive or negative feelings in tweets about NYU.
Oh, interesting. You couldn't easily do that in the regular app.
Not really. And another was a tool called Swak, which apparently lets you search and filter your Twitter followers in much more detailed ways than Twitter itself allows.
So these tools exist because Twitter made its public API available.
Exactly. Without that public API, those projects wouldn't be possible. Companies offer these public interfaces, and it lets other people innovate using their platform's data or features.
What's in it for the company, like Twitter? Why let others build stuff using their system?
That's a really key point. It creates an ecosystem. By offering public APIs, they encourage developers to build tools and services that make the core platform more valuable.
So more tools using Twitter data might bring more users to Twitter.
Potentially, yeah. Or find new uses for Twitter they hadn't thought of. It extends their reach, creates network effects. The more people building on the API, the more valuable Twitter becomes. Of course, they also have to think carefully about security, data privacy, and how much access they grant.
Right, it's not just wide open. Okay, so internal APIs, public APIs. What's the third way the term is used?
The third one, and sometimes this is the one that feels a bit different, is using API to talk about code interfaces. We're zooming in quite a bit here.
So not between different apps, but like within the code of a single program.
Exactly. It refers to the lower-level inputs and outputs of specific functions or methods within a programming language itself, like a mini API governing how different pieces of your own code interact.
Okay. Give me an example.
Think back to that JavaScript array.sort method. We called it an API earlier. Within JavaScript, that is considered the API for sorting an array object.
Its input is the array itself, and its output is the sorted array.
Basically, yes. The array is kind of the implicit input it operates on. And the source listed other common JavaScript array methods, too.
Like push and pop.
Yeah, array.push. To add something, array.pop.
Yeah.
To remove the last thing, array.filter. To create a new list based on some condition. Even just array.length to get the size.
So all those little built-in functions or methods in a language, those are APIs too.
In this context, yes. Developers use these APIs constantly when writing code. They provide defined ways to interact with data structures or perform common tasks. Even a super simple function like add AB that just takes two numbers and returns their sum.
Yeah.
That function has an API. Its API takes two numbers, AD as input, produces their sum as output. It's a contract for how other parts of the code should use it.
Okay, wow. So API really does cover a lot of ground, from huge systems talking to each other down to tiny functions inside one program.
It does. It can mean the big picture interactions between different web services or these really fine-grained interactions within your code. It all comes back to that core idea. Defined inputs, predictable outputs.
Which is probably why the source included that bit about how you hear API used in actual conversations, right? To nail down these contexts.
Yeah, exactly. Those examples were quite helpful, I thought.
Like, if someone on a dev team says, we're still figuring out what the API for this new feature will look like.
They're probably talking about designing an internal API, right? Defining the inputs and outputs for a new part of their own application, how it will connect to the rest of their system.
Or if someone says, you could use the Twitter API to get that data.
That's clearly referring to a public API, using Twitter's published interface to pull information programmatically.
And the classic developer complaint. Arc, the API keeps giving me this weird off error.
Yeah. That's about the practical, technical interaction with an API, internal or public, and hitting a snag, getting an unexpected, though maybe predictable, error output.
Right. And finally, someone might say, hey, I built an API that finds the 10 closest taco trucks.
And there, they're talking about creating a new service with an API. They've defined an input, maybe your location, and an output list of taco trucks, hoping maybe other developers will call their API.
Okay, so quick recap of the main terms then. We've got API itself, the core idea.
Inputs and outputs, the specific data going in and coming out.
API calls the act of requesting something from an API.
Public API versus internal API, who gets to use it.
And front end, the user interface, what you see.
At back end, the engine, the logic, often powered by lots of APIs working together.
Got it.
So I think the main takeaway really is that APIs are just these absolutely essential building blocks for modern software. They're the intermediaries.
The drive-through windows.
The drive-through windows, taking specific inputs, giving predictable outputs, letting different software pieces talk and work together, whether they're parts of the same app or totally separate services online.
And we know the word API pops up in those different contexts. Internal workings, public interfaces for innovation, or even just the basic interfaces within code itself.
But it always boils down to that input-output contract.
Okay. So that leads us to the final thought, the provocative idea to leave people with. This came from the further reading in the source material.
Yeah, it's a really interesting extension of all this. Think about this. What if you could build entire complex applications just by connecting different APIs together?
Like Lego bricks, but the bricks are APIs.
Kind of, yeah. It's this idea called microservices, where applications aren't one big monolithic block of code, but rather a collection of smaller, independent services that communicate purely through APIs.
How would that change things?
Well, think about it. How might that approach, building everything from these interacting API bricks, fundamentally change how software gets developed? Could it make things more flexible, easier to update, more scalable?
You could swap out one microservice, one API-driven piece, without rebuilding the whole thing.
Potentially. And beyond just development, how might it change the way different online services interact in the future? Imagine a world even more interconnected, driven entirely by these API conversations happening constantly behind the scenes.
A web of interacting services, all talking via APIs.
It's definitely something to chew on, a fascinating direction to think about.